going to be factoring quadratic trinomials, but this time with the greatest common factor, a GCF. So we're going to be following the same steps we've been following every time for factoring. Like here, we've been factoring things like this. 3x squared plus 7x minus 6. And our first step would be to multiply a times c to get negative 18 and write out all the factors of negative 18. There they are. I'm going to find the pair that adds to positive 7, which is this one. This pair right here adds up to positive 7. So I'm going to split up this 7x into negative 2x plus 9x. So the 3x squared doesn't change, but then we're going to have, I'll do the plus 9x first, minus 2x, minus 6. So this negative 2 and this 9 replace this positive 7. Now I split it in half. Out of the left half I can factor out a 3x, leaving me with x plus 3. Out of the right half I can factor out a negative 2, leaving me with x plus 3. So I'm left with 3x minus 2 times x plus 3. That is how that factors. That's review of what we've done in the past. Well, now we're going to add in one more layer, one more step. And that is a GCF, a greatest common factor, that I'm calling step 0. Step 0 will be to factor out a GCF if possible. So I look at a problem like this, an expression like this, and I first ask myself, is there any term, any number, that each of these terms has in common that I can factor out? In this case, there's a greatest common factor of 2. Each term can have a 2 pulled out of it. Now you'll note here, there wasn't a greatest common factor. I couldn't pull 3 out of everything, so I can't pull 3 out of this 7. So this one didn't have a GCF. We could say the GCF is 1 if we wanted to, but we're not going to factor out a 1 in that case. But here, I can pull a 2 out of everything. That leaves me with 3x squared plus 7x minus 6. Now, I just factor this. And, for the record, we just did factor that. This is the same thing here. So I know this is going to turn into 3x minus 2, x plus 3. Because I can just follow all of these steps right here. So we factored it by pulling out a GCF first, and then factoring whatever was left, factoring the stuff that's left after you pull out that GCF. Okay, so that's it. We'll do a few example problems, but that's the drill for today. Okay, so let's do one down here. I'm going to factor this one. Now, every term here can be divided by 2. But since the leading coefficient is negative, I'm going to say the greatest common factor is negative 2. So I'm going to factor a negative 2 out of all of this. Now, I have a new a, b, and c term. I don't use the old a, b, and c's. So my a value is 1, my b value is 7, my c value is 10. Okay, I'm not using negative 2 and negative 20 for my a and c terms. I'm using 1 and 10. So my factors of 10 are 10 and 1 and 5 and 2. This is the pair that I want. Now you have two options. One option is you just keep factoring here. And as you keep factoring here, the negative 2 is just going to sit there every single time. That's a fine option. I'm going to factor the stuff here. So I have x squared plus 5x plus 2x plus 10. Slash this in half. I can pull an x out of the left half and a 2 out of the right half. And I end up with negative 2 times x plus 2 times x plus 5. And there. I factored. It's beautiful. The other option is sometimes having that negative 2 out in front confuses people. So you can just take this and pull it off to the side and factor it here. Notice I switched the 2x and the 5x just to show it doesn't matter. It doesn't change anything. I can pull an x out of the left side and a 5 out of the right side. And you get x plus 5 times x plus 2. And then remember there's a negative 2 in front of it, so tack on that negative 2 in the front, and there's your factoring. Okay, so all the same steps. We just add 1 in the beginning, factor out the GCF if possible, and it's not always possible. Last one. This is a bit of a different strain of thought here. How would you factor x squared minus 49? And I'll tell you it can factor. How would you factor it? It's going to factor into something like this with the two bubbles, the two factors. Remember, you can always just play with a, b, and c. Your a value is 1, your b value is 0, and your c value is negative 49. So I want two numbers that multiply to negative 49 but add to 0. Turns out it's negative 7 and positive 7. So I'm going to have x squared minus 7x plus 7x minus 49. I'm factoring this right now. Cut it in half. I can pull an x out of here and a positive 7 out of here. So it becomes x plus 7 times x minus 7. Whenever you have a perfect square minus another perfect square, it'll be factorable. It actually factors into the square roots of your numbers. Little trick that isn't necessary but pretty helpful. Alright, y'all. Thanks for watching. See you next time. We did it! We got through another math video. Thanks for watching. Here I'm going to play with the perspective on these shapes while I talk to you. Please subscribe to the videos, like the videos. Okay, start this thing over. You did it! You got through the video. Thanks for watching. I'm going to play with the perspective of these shapes, which is always pointing towards that center while I talk to you about things. Please subscribe to the video, the channel really. Please like it if you found it helpful. If you want to share it with friends and say, hey, this guy's not the worst, that's an option too. You can always take your video quiz if you're in my class. And comment down below. See you next time.